Welcome back, or if you haven't watched any of my other videos, then just plain welcome. Um, in the last couple of videos, we were talking about factoring quadratics, and we looked at our easy case, which one of our examples was this, and we ended up factoring that out, and you can go back and you can see how to do that. I recommend checking that out, or at least being comfortable with it, as we will use it some in this lesson. And also, more importantly, you need to start to have already gotten your feet wet with quadratics before you start looking at more difficult cases. Make sure that you're comfortable with each step before you move into the next one, because that's how you build confidence. And you don't have to look at a quadratic and be like, yes, this is what I want to do with my life, is solve these quadratic polynomials. There's nothing better. But you need to not freak out when you see it. So whenever you see these, if you just raise your fists in anger and scream at the sky and no, not another one, that's not what we need. So without further ado, let's look at something more difficult. Now, when I say we had the easy case, it's because there's nothing in front of x squared here. So we can just look for what multiplies to 6 and adds to 5. Now, that's not too bad, hopefully. So we would like things to look like this. So if we see something with a number in front of our x squared term, then hopefully we can change it back. So let's look at an example like that first. If we had 2x squared plus 10x plus 12, and let's just go ahead and set it equal to 0, we'll solve it. The first thing that you should look at and see is, oh no, there's a 2 in front of this. Well, let's hope that we can make this easy, because as mathematicians, we're lazy. So we're going to try and take the easiest way out first, because why not? Does 2 go into 10? Yes. Does 2 go into 12? Yes. So we can factor a 2 out of everything. So 2 is our greatest common factor of all the terms in this polynomial. So if we pull a 2 out, in our first term we're going to be left with x squared. 10 divided by 2 is 5, so for our second term we'll have 5x. And then 12 divided by 2 is 6, so we're left with 6. Now if you multiplied this back out, hopefully you can see that we'd get back to this. But we're trying to kind of go backwards from that, because now you'll notice we have more familiar territory, which is good. You should always try to come back to something that you understand whenever you see a problem that's difficult, because then you won't freak out as much. I do it, everyone does it. So in this case, it works out very nicely, because as we saw last time, x squared plus 5x plus 6 just factors to be x plus 3 and x plus 2. We just happen to have that 2 out front. Now, I can divide both sides by 2. 0 divided by 2 is just going to be 0, so all I'm left with is the x plus 3 and x plus 2. Then I would set my x plus 3 equal to 0, my x plus 2 equal to 0, and just like we had in our last video, x is going to end up being equal to negative 3 and negative 2. Not too bad. It's just one extra step. So this would be the next easiest case, the thing that we hope for. So we look in front. If we don't see anything, great. We factor, we're good. If we do see something in front, we hope that we can factor something out. Then we go on, and we're good. Let's look at another one just for some extra practice. Let's say that we have 3x squared plus 21x plus 18. Notice we have a 3, so let's hope 3 comes out of everything. Does 3 go into 21? Yes, 7 times. Does 3 go into 18? Yes, 6 times. So we're factoring out a 3. 3 times x squared makes 3x squared. 21 divided by 3 is 7, so we have 7x for our middle term. 18 divided by 3 is 6. So we don't have anything in front of our x squared anymore, so now we're back in familiar territory. Let's just go ahead and get rid of our 3, because we can divide it, just like we did over here with our 2. So we really have x squared plus 7x plus 6 equals to 0. Now, we're looking for what multiplies to 6 and adds to 7. So, make our big X, 6 and 7. What are my factors of 6? 1 times 6, and 2 times 3. 2 plus 3 is 6, so that doesn't help us. 1 plus 6 does help us, because that gives us 7. So we're going to use 1 and 6. So this will factor to x plus 6 and x plus 1. If you multiplied that out, you would get back to this. You can always check it. In fact, I encourage you to, just for extra foiling practice. Now, I'd have x plus 6 equals to 0, x plus 1 equals 0, subtract 6 across, x equals negative 6, subtract 1 across, x equals negative 1. Yay, we're happy. We came to our answer. Not too bad. It's just one extra step. Now, the reason that we can get rid of this 3 is, and we'll go into this more later on, we should be thinking of the shapes of these graphs. So, in this case, we hit at negative 6 and negative 1. So, very, very roughly, and excuse my lack of artistic skills, let's say we've got a parabola that looks something like that. That almost hit those points. And actually, pretty good for me. Whenever I have the 3 in front, it would hit in the same places. It would just be a little steeper, because that's doing something called a vertical stretch. So it would hit the same, it would just be bigger. All my answers would be multiplied. So instead of going in, whenever we're doing x squared, 1 squared is 1, negative 1 squared is also 1. But imagine this as having the 3 out front. So my answers would also be multiplied by 3. So I would still have 1, but instead of going up 1 over 1 up 1, I'd go over 1 up 3, which is where this stretching happens. So that's why it's okay to divide by the 3. That's just a little preview of what we'll eventually get into. But for now, let's just stick to solving. So, now, as with every easy case, there is also a difficult case. And because I don't want you to freak out about that either, we're going to look at something called splitting the middle term and then factoring by grouping. So, we'll go at it all at once. Let's look at 2x squared plus 3x minus 5. Now, we notice that we have a 2. First thing that we should look and hope is that 2 goes into everything. 2 doesn't go into 3, so we're already screwed on that front. So, let's take a look and see what else we can do. The trick here is we are going to multiply our 2 and our negative 5. 2 times negative 5 is negative 10. Then I need to add something up to make my middle term, which is going to be the 3. So, we're going to look for something that multiplies to negative 10 and adds to 3. I'll explain more about this multiplying step here in a second, but trust me for now, and we'll get back to that. So, things that multiply to negative 10 would be 5 and negative 2, negative 5 and 2, 1, negative 10, negative 10, and 1. Now, 5 plus negative 2 is 3. So, there we go. Just so happens that the first one we tried worked. Negative 5 plus 2 would be negative 3. 1 minus 10 would be negative 9. Negative 10 plus 1 would be negative 9. Whoops, that should have been positive and that should have been negative. But it still doesn't work. Hey. Anyway, so we lucked out and our first set works. So, at this point, this is where the splitting the middle term comes into play. As I've said with mathematicians being lazy, they're also lazy at naming things. They're not going to come up with something difficult, and you do have certain theorems that are named after people, but again, even then, it's just named after who discovered it. In this case, it's called splitting the middle term because we're going to take the middle term and we're going to split it into 2 terms. Not very creative, but easy to remember. So our 2x squared is going to stay there, and we're going to have to choose which way to write this. I'm going to write plus 5x minus 2x minus 5, just to demonstrate a point. and I'll explain that in a second. What's going on here is 5x minus 2x equals 3x. So we haven't changed anything except the way it looks, because again, changing the way something looks can make it easier. And that's the whole point here, is to make it look differently so that we can have an easier time with it. Now comes the factoring with grouping part. So I'm going to group my two terms together here and my two terms together here. Can I pull anything out of 2 and 5? No. So, all's not lost. All that means is that we need to switch the order that we wrote these two in, and that's why I did that. When you find these, if you can find something that multiplies to our top and adds to our bottom, then we're on the right track. We know something will work, we just have to figure out what it is. So if you get here, don't freak out and start over assuming you did something wrong. Try switching them around and see if it helps. So let's write 2x squared minus 2x plus 5x minus 5. And lo and behold, something comes out of these two. For my numbers, I can pull out a 2, and they both also have an x in common. So I can pull out an x. This is more on the greatest common factor, and I'll put up some more practice on that later on if you're uncomfortable with that, because it is very crucial to this. So if I pulled out 2 and x, 2 divided by 2 is 1, and if I pulled out one of my x's, I have 1x left over. 2 divided by 2, I have negative 1, and then I pulled out my x, so nothing's left, so I'm left with x minus 1. What can I pull out of 5x and 5? I know I've got a positive 5 in common, and both don't have an x in common, so I can't pull anything else out. So if I took my 5 away, I'm left with x, and negative 5 divided by 5 is negative 1. Now what's important here is what's in parentheses we have in common. So this factoring by grouping comes into play by factoring out and then factoring out again. So what we're looking for is what we have in common. These two, this x minus 1, is what we have in common. So that's what we're going to factor out. Then we look at what we have left over. If I took my x minus 1 away, I'm left with a 2x here. If I took my x minus 1 here away, I'm left with a positive 5. Now, let's just pretend for a second we had 2xy plus 5y. What do I have in common? Just my y's. So I pull a y out. Then if I took my y away, I'm left with 2x. If I took my y away, I'm left with 5. So notice, this is the same thing as what happened here. It's just instead of y, I have x minus 1. This x minus 1 is a big thing. This big thing is in common. And it doesn't matter how many terms or how ugly your thing is, if it's in common, you can pull it out. So it's this same idea of factoring out that we should be getting used to. So that's why this is the factoring out lesson. Anyway, back to over here. We can see now we have two factors. And that's what we wanted to do. We wanted to factor this. So, for grins and giggles, let's set it equal to 0 and solve it the rest of the way. We have x minus 1 equals 0, and 2x plus 5 equals 0. So, add 1 to both sides to get x by itself, and we're left with x equals 1. Over here we'll have two steps. I have to get my x term by itself first, so I'm going to take 5 away. So I have 2x equals negative 5. Then to get x by itself I have to divide by 2. So I have x equals negative 5 halves. So I have x equals 1 and x equals negative 5 halves. To figure out if you're right, you would plug 1 back into your original equation and negative 5 halves into your original equation. And if it equals 0, then you've done it correctly. And hopefully when you plug it in, you'll see that we've done it right. I encourage you to try that again for the extra practice. So we went through a lot here. If you've never seen any of these steps before, then that's why we're about to do another example. So first step is to multiply our first term, our first coefficient, by our last coefficient. That got us our negative 10. Then we're in semi-familiar territory where we're looking for something that multiplies to negative 10 and adds to 3. Hopefully at this point you're used to that. That's why I said to be practiced at it. So we found 5 and negative 2. Then we split the middle term. we have two new terms that will go in its place that is still the same value, but it looks differently. Then we figure out how we can group things together. Once we group things together, we should have something in common. That something in common will be one of our factors, and what's left over will be our other factor. Then, after we have it factored, we are back in completely familiar territory where we're just solving for 0, as this piece being 0 or this piece being 0. Then we've solved it. You may want to watch that portion again, or you can keep going. I'll go through one more example. Let's say that we have 3x squared minus 10x plus 8. Now, the other three examples that we did, I had written out and solved beforehand. For this one, I have not solved this one yet. I know it can be solved, but I haven't solved it yet. Now, the reason for that is if I am unprepared to solve this, then you will get to see my thought process, and you can do your best to mimic it. It's a trick that I learned from my calculus professor when I was in college. Because he was unprepared and I got to see his thought process, I got to see how he thinks through something, how you can tackle a problem. It's great to see me work through problems that I know how to do, but seeing me encounter a problem for the first time and solve it, hopefully that will help you tackle problems on your own. Because I don't want to just prepare you to solve quadratics, I want to prepare you for problem solving. And that's what this is. We need to solve this problem. So I know the first thing that I need to do is multiply 3 and 8. So 3 times 8 is 24. It's positive. That's nice. Then I need to add to make negative 10. So because I need something that multiplies to make a positive, I'm either going to need both positive or both negative. Since this is a negative, they're both going to have to be negative, because only two negatives can add to make a negative. Two positives won't work. So I have factors of 24. That's annoying, because there's a lot of factors of 24. So we've got 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that should be it, because 5 doesn't work, and then I get back to 6, and 6 is already paired with 4. Now, because I'm pretty practiced at this, I know 4 plus 6 is going to be 10. So I'm going to choose negative 4 and negative 6. For you, you may have to try 1 and 24, 2 and 12. Hopefully you see really quick that none of these add up to 10, and you'd come to this as your conclusion. Again, I'm a little practiced at this, so I have an idea of what's going on. So, now comes time to split the middle term. I have 3x squared, something something, plus 8. Now, my two terms are going to be negative 4x and negative 6x. I'm going to put the negative 6x first, because I know I can pull a 3 out of 6 and 3. I'm going to put the 4 next, because I know 8 and 4 both have 4 in common. So, with a little intuition there, I can write it correctly the first time, and not have the mistake we did last time. If you accidentally write them in the wrong order, just switch them and try again. That's why I showed you that way last time. So, now comes the grouping part. What can I pull out of 3 and 6? 3. So, I'm left with x squared there. Negative 6 divided by 3 is negative 2. Oops, that should have been x. I apologize. Part of the unprepared thing. What can I pull out of negative 4 and 8? I can pull out a negative 4, and the reason is because I want this to be positive. So what's negative 4 divided by negative 4? Positive 1x. 8 divided by negative 4 is negative 2. That way what I have inside is in common. If I just pulled out a positive 4, I would have been left with negative x plus 2. That's not the same thing. So, x minus 2 is what I have in common. That will be one of my factors. What I have left inside is 3x minus 4. Now, because I just did this for the first time, and I want to make sure that I'm not leading you astray, let's go ahead and multiply this out just to make sure that we got the right answer. So, x times 3x is 3x squared. We're off to a good start. X times negative 4 is negative 4x. Negative 2 times 3 is negative 6x. Negative 2 times negative 4 is 8. So let's combine our like terms. 3x squared. Negative 4x plus negative 6x is negative 10x plus 8. Yay, we got it right. So now, from here, we'll do our factoring. X minus 2 equals 0. 3x minus 4 equals 0. Add 2, x equals 2. Here we have 2 steps. So we add our 4 to get our 3x by itself. Have to get rid of that 3. X equals 4/3. I'm fine with leaving your answer as an improper fraction. Your teacher may not be. This is why fractions are good and fractions are our friends, because you'll get a lot of fractional answers whenever you have these two-step situations. So, being able to recognize them, another key skill. So, yet again, we solve. Now, just because why not, let's go ahead and plug this in. So I'm going to try my 2, plugging it in the place of x. And let's see what we get. 2 squared is 4. 4 times 3 is 12. Minus 10 times 2. 10 times 2 is 20. Plus 8. 12 minus 20 is negative 8. Plus 8 equals 0. So far so good. Now you get to watch me play with fractions. Aren't you lucky? Squared minus 10 times 4/3 plus 8. Now, whenever you're squaring a fraction, you simply square the top, then square the bottom. So I'm going to have 3 times 16 over 9 minus, multiply onto the top, 40 over 3 plus 8. Now, 3 times 16. We could do that, or we could recognize that the 3 on top is going to cancel with 3 on the bottom. So, what I'd really have is 16 over 3 minus 40 over 3 plus 8. 8 I can't deal with because I don't have the same denominators, so I need to change it. So, that would be the same as 24 over 3. 16 minus 40 is negative 24 over 3 plus 24 over 3, which is 0. So again, we're right. So in both cases, things worked out. Therefore, our answers are correct. Again, this is going to take some practice. Now, as I said before, I'm going to explain why we multiply our 3 and our 8. Our first term and our last term. The reason is because there's a couple of ways that I like to think about it. Whenever there's nothing in front of your x squared term, you're still technically doing this. It's just that 1 times whatever is over here is just this. So we're still following the same process. It's just a little uglier with an extra step. The reason that we multiply this through is whenever we have this term that we pull out and we're left with something over here, instead of it being nice and simple where we just have x plus or minus something times x plus or minus something, we always get x plus or minus something times something x minus something. We're dealing with the something. So, because we have this something here to multiply, we're having to multiply those together. It's undoing that step. What I recommend is practicing this and foiling out a lot to see where it comes from. And that way, you're not just arbitrarily memorizing processes. I'm not a big fan of memorizing. I like to be able to derive it out every time, so that's the way that I teach it. However, at the same time, I like to demonstrate it in a way where those who like formulas can see it. That way they're comfortable as well. Because it doesn't matter what way you learn, what matters is that you do. So hopefully I can touch on any way that you need. If there's other ways that you like to do it, by all means, leave it in the comments and make it a great math discussion. Nothing would make me happier. So this is splitting the middle term and then factoring by grouping. As I said, I'll do a factoring by grouping video eventually so that you can get more practice with each individual step. Because this is a series in quadratics, I assume that there is at least some knowledge in how to do that so that we can actually solve the quadratics. Next time, I will talk more about different forms of quadratics and different ways to see them, particularly cases where we have something x squared minus something that is a perfect square equal to 0, and different ways that we can solve those, and some other special forms before we get to the dreaded quadratic formula. But that one is coming, so be on the lookout for it. If you liked the video, be sure to subscribe, like it, all that jazz, but hopefully it's just teaching you something. So, thank you.